I'm Kara Lawson.
I'm Guoliang Wang.
My name is Luke Waltz.
My name is Vinayak Shedekar.
My name is Horacio Lopez Nicora.
I'm an assistant professor in agricultural communication.
A professor in the Department of Plant Pathology.
I'm a PhD student in the Food, Agricultural, and Biological Engineering Department.
I'm the state specialist for agricultural water management.
I'm the soybean pathologist and nematologist in the Department of Plant Pathology here at Ohio State University.
My project explored risk perceptions of people around the United States when it comes to climate change.
The goal of this project is to test the effectiveness of a new biopesticide for disease control in tomato.
It's really about trying to mitigate these unpredictable extreme weather conditions that now growers are faced when we're ready to plant our seed.
We wanted to really build a data set and use machine learning to predict growth stage of crops using drone UAS imagery. We wanted to predict soil moisture using sensors we put in the ground. And then we also wanted to predict yield.
What we have done so far over the last year or so is look at automated drainage water management as a practice in comparison with a manual approach.
I'm really happy to report that we were able to meet all the objectives that we set forth. Some of the key findings in this study really surprised me a little bit, and the first piece that was kind of surprising was that most of the participants had a pretty neutral view of climate risk.
In the greenhouse experiment, we found that the new biopesticide can reduce disease severity by 50 to 60% in both tomato and cucumber. In the field experiments, we found that the biopesticides can reduce disease symptoms by about 50%. Lastly, we developed a cost-effective production methods for the biopesticides.
Thanks to this project, now we have very well and standardized protocols, and knowing exactly for all of these pathogens that are present in Ohio, what's the optimum condition. And understanding and knowing this will allow us to develop models to be able to predict risk in certain areas and moments.
So our research went well. What we proposed to nationwide is that we wanted to predict yield based on things like soil moisture, meteorological data, and growth stage from drone imagery. And so we were able to collect the data across Ohio at OSU research stations, and we were able to really put together some models that we thought did a reasonable job of predicting yield.
In the zones where we applied this automated approach, which was more active way of managing water, we did see some evidence of a little more moisture that was conserved. We saw definitely an increased crop respiration capacity for the crops that were under automated control drainage.
As scientists, I think we're prone to go into a lot of conversations with data and figures and numbers, which are certainly powerful, but so often I think it's easy to overlook that emotional connection that people have to the issue. So with these data, we have a little bit more insight as to how people feel about the issue.
We were able to invite very prestigious researchers that are the experts on seed health, seed physiology, seed quality. Not only that, we were able to offer 2 courses, one in the Department of Plant Pathology and one in Horticulture and Crop Sciences.
We have obtained the preliminary data from greenhouse and field. The next step is we do more field experiments and also do toxicity assay.
Actually taking the data from its raw form in the field to getting it ready for machine learning was not something that was a solved problem. We were able to collaborate with an AI institute on campus called Icicle to really build some pipelines that would be able to make that happen much quicker.
I think this project really gave us the opportunity to engage with the producers and have those conversations that are very difficult for us to have otherwise.
The nationwide funding really helped us identify key variables that ultimately affect seed health and seed physiology. And by doing so, we can now integrate this in predictive model that can help us assess risk.
Up to this point in time, there weren't a lot of studies out there that looked at climate risk perceptions from a national and regional level. So thanks to Nationwide for funding this study, we are now able to have a pretty good idea of what's going on in the minds of people in the United States.
The funding from Nationwide have helped us obtain the greenhouse and the field data the MTD4 technology is highly efficient in developing biopesticides and biostimulants into plants for sustainable crop production.
I feel like we have delved into a sort of a newer area where we're not just looking at the water dynamics, but we're also looking at the crop response. And it's interesting that the crops are actually more responsive to this little tiny changes that you see in the water budget, in the soil profile. So that was the exciting part for us, really helped us build that interdisciplinary team that didn't just stop with the nationwide funding. We actually were able to leverage some of this research into additional research ideas that recently got funded.
The nationwide funding has been really critical for us to build this data set across these 3 OSU locations. We built on existing Battle for the Belt planting day study, so we didn't have to build the study from scratch. We were able to then use the sensing equipment, the drones, to really put this data set together. So we were able to take the nationwide funding and really amplify it and augment it to really do some meaningful things in agriculture.